Hi guys, this is Nitya, Assistant Professor of Mathematics from St. Anne's Arts and Science College. Today we are going to see the divergent sequence, oscillating sequence as well as the examples based on that. So let us see the first definition, divergent sequence to plus infinity. So it has a limit as plus infinity. Let Sn, the sequence Sn, where n is lies between 1 to infinity be the sequence of real number. Then we say that Sn approach to the infinity as n approaches to infinity. So when n approaches to infinity, the Sn, that is a limit, approaches to the infinity. If for any real number m greater than 0 we are taking, and there exists a positive integer capital N such that Sn, small n, is greater than or equal to m, where n is greater than or equal to n, that is m, not n, m is greater than or equal to n, we write Sn tends to infinity as n tends to infinity, or we say that this diverges to infinity. So it is a definition, important definition, which they will be asking in 2-mark question. And then divergent sequence to minus infinity, this is also important definition. So let us Sn be the sequence of real numbers n equal to 1. We say that Sn approaches to minus infinity as n approaches to infinity. For any real number m greater than 0, there exists a positive integer n such that Sn is less than or equal to m minus m. Okay, so it diverges to minus infinity. Now we can see the examples. Show that the sequence n equal to 1 to infinity divergent to infinity. So let us take Sn equal to n, the sequence for given m equal to m is greater than 0. First we have to choose the n belongs to I. First we have to choose n belongs to I such that n is greater than or equal to m. We are taking the real number n. Then certainly n is greater than or equal to m, we know by the definition. Now Sn is greater than or equal to m and n is greater than or equal to m. Therefore Sn tends to infinity as n tends to infinity. Next question, let us show that the sequence Sn, where Sn equal log 1 by n, divergent to minus infinity. So we have to take the minus m value. So given m is greater than 0, so we must find n belongs to I such that Sn less than minus m. So log of 1 by n, the given sequence which is less than minus m. Multiply by minus on both sides. So what will happen? Minus log 1 by n is greater than m. So minus log 1 minus log n is greater than m and n is greater than or equal to n. So here log n is greater than m, where n is greater than or equal to n. Now apply the e. So e power log n is greater than e power m and n is greater than or equal to m. Therefore e power log is n. E power log n is n, which is greater than m. So n is greater than or equal to n. Thus we choose n is greater than e power m. So this diverges to minus infinity. This diverges to minus infinity, this term. So we are choosing n is greater than n is greater than or equal to e power m. Greater than, this one should be greater than e power m. So obviously this should be diverges to minus infinity. Next question, show that the sequence root of n diverges to infinity. So as usual, given m greater than 0, we find n belongs to n. Sn is greater than or equal to m. Therefore root n greater than or equal to m, where n is greater than or equal to n. So root n is greater than or equal to m. And if we choose n is greater than or equal to m squared, if we are taking root to be this side, then m squared will come. Therefore the sequence diverges to infinity. If you are applying the values, then it will be easy for you. While we are seeing that only the alphabetical terms, it is tough for us to find the real analysis. But if you are applying some values, suppose 2 or 3, and you can choose m as some value and small n as some value, then it will be obviously easy for us to understand. Next, oscillates definition we are going to see. If the sequence Sn of real numbers diverges but does not diverges to infinity and does not diverges to minus infinity, we the sequences oscillates. Suppose if we are having the infinity and minus infinity, the sequence does not diverges to both of the infinities, right, plus and minus value, then we can say that it's oscillates. Yes, Generally we know that the oscillate meaning is it should not be standing one side and it has to be oscillate everywhere. Suppose if you see the clock, the in the olden days we have the clock, we have that pendulum will be there in the clock, it will be oscillates every time this side moving onwards at this time. I think some of you have seen in your grandparents' house. Or you can take it as a swing. We know we can play a swing. So while we are sitting in the swing, it should not be come in stand in one place. So it has to be, if you are moving that, it has to be oscillate, come and fro, back and front. It will be oscillate. So likewise here also the diverges means it diverges. It does not diverges to the infinity and minus infinity, the sequence. So it will be moving on. So it is a oscillate. It is mean that oscillates of divergent oscillating. So for that the sequence -1, see the examples, -1 n tends to n equal to 1 to infinity. So what will happen? -1 1 -1 1, it will be moving on like that. It doesn't have any limit. So it is a divergent oscillating. See the next example, 1 comma 2 comma 1 comma 3 1 comma 4 1 comma 5 and so on, it will be moving on. So this also diverges. Since it has a divergent subsequence 1 2 3 4, moreover the sequence does not diverges to infinity. Since there is no NGNCI, that is oscillating divergence, for which the statement Sn is greater than or equal to 2 is true, the sequence obviously does not diverges to minus infinity. That is Sn greater than 2 in the sense the sequence should be always greater than 2, not less than the 2. So if you are taking that, it has to be a oscillating divergent sequence. See the next example, 1 -2 3 -4 and so on. So here it does not approach to infinity or minus infinity since it's a divergent oscillating, but the subsequence, from the subsequence we are taking 1 3 5 and so on, it approaches to infinity. So the subsequence -2 4, this approaches to minus infinity, hence it's oscillating. So I think the third example is very clear for divergent oscillating sequence. So the sequence I have taken as 1 -2 3 -4 and 5 -6 and so on. Here we are taking only the positive terms, that is 1 3 5 s, it will be approaches to infinity, and taking the -2 -4 -6 subsequences approaches to minus infinity. So we are having that sequence should be oscillating both of the sides. So it's a oscillating divergent sequence. So it is clear. Beyond to the first and second example, it is very clear. Third example. Next one, the example of the convergent oscillating. First we had seen the divergent. Now we are going to see the convergent oscillating. What is the convergent oscillating? If Sn is a sequence convergent to the limit L. Generally, you know that if it is any sequence, if it is a convergent means it has a limit. And if any sequence we are taking, if it is a divergent means it doesn't have limit. Already we had seen in the definition of convergent and divergent. Now we are going to see the convergent to L. Then the proof that -1 the whole power n into Sn is oscillate. If any sequence we are taking that it's converges to L, and also they have given that -1 the whole power n into this sequence Sn is oscillate. So if you are multiply the -1 the whole power n with that sequence, it should be oscillated. So write the given statement. If Sn is converges to L, every subsequence of Sn converges to limit L. Now given that S equal to, let us take S is equal to -1 the whole power n Sn. So this can be written as -S1 S2 S3 S4 and so on. Now S has the following two sequences, -S1 -S3 -S5 and so on, as well as the plus values also, positive and negative values. So Sn converges to L is a given limit. So therefore Sn S3 S5 and S2 S4 also converges to L, but minus S1 S3 S5 also converges to L. Therefore as a two convergent subsequence, one converges to L, another one is converges to minus L. That is the difference. So it is oscillates. So there we are in the definition we are seeing convergent to infinity and minus infinity. Here convergent to L, the limit they have given, so it's convergent to minus L. The positive terms to be convergent to L, negative terms to be convergent to minus L. Therefore, the sequence minus 1 the whole power in Sn is oscillates. Okay. So today we had seen the divergent sequence to infinity and minus infinity, as well as oscillating sequence to infinity and minus infinity. Oscillating divergent, oscillating convergent auto also we had seen. So go through it, watch it. If you have any doubts, you can call me, girls. Okay. Thank you.